Hi, in this video we'll be learning what is piezoelectric effect and how the piezoelectric energy is being generated and how it is utilized, and also the piezoelectric energy harvesting methods are also analyzed in this video. A major part of the electrical engineering concentrates on different new updated ways of generating electricity from various sources of energy which is prevailing around us. And the most important part is, or the focus is on how to condition it. So generally we'll try to convert any sort of energy, or specifically mechanical energy to electrical energy. Mm, and if it is done this sort of by sensing, converting mechanical energy to directly electrical energy without any mechanical rotation or any type of generator has been used, then that is falling into the category of piezoelectric effect, or the piezoelectric generator, which actually does not need any moving parts because it's very compact. It is does not have any moving parts. It's very compact, reliable, and long lasting, and it also makes conditioning of the signal easier. So this helps us to extract the energy in a easier way. There are many types of piezoelectric elements like you know quartz that is shown, which will be shown in the later cases. See, these are the different types of elements that is available in different types of varieties of shapes of piezoelectric and energy harvested part generators. So generally the piezoelectric energy, piezoelectricity, it's very simple. This is how it is going to be. It has a positive terminal and a negative terminal. The concept behind that is, when you apply mechanical stress over that particular material, as I said, quartz or ceramic, lead, zirconite, titanate, LZT, yeah, or PZT, we call it as PZT, and even some other naturally available biological materials like bone or DNA. When a stress is applied over that, obviously an electrical energy is being generated. So the actual mechanism involves the generation of electric dipoles, which are of two opposite charges generated by a small distance. So this is what it is, which can be loosely compared to a bar magnet in a crystal structure. So when a force is applied to the crystal, small changes in the structure actually happens. Uh, this lattice induces the formation of an electrical dipole, and which in turn produces a voltage across the faces of the crystal. This voltage makes available a small amount of charge that can be used to power an external circuit if it is connected, or you can just store it in a battery also. This effect also works in reverse, means a voltage applied to a piezoelectric element will result in it deforming the plane, along a plane. So this is how the piezo buzzers and ultrasonic transducers work. And each atom, here carries with it a small charge. In case of quartz, the oxygen atom carries a negative charge, and the silicon atom, you know uh, a positive charge. So since the atoms are all arranged at an equal distance from each other, the charges are balanced and there is no net dipole moment. So when the crystal is deformed along two opposite sides of the hexagon, the structure is flattened, and now the distance between the opposite vertices increases at the ends. This causes an imbalance of charges along a central axis, creating a small dipole moment. So that's how the dipole moment induces a small amount of voltage across the crystal perpendicular to the applied force. Okay, so this is how the piezoelectric energy is actually obtained, and you can see how it has been conditioned, as I mentioned in the beginning of this video itself. So the power source formed resembles like a capacitor. Yes or no? Like I've seen, right? The force is applied and it acts like a two plates of a capacitor. And so what happens is the output is a high voltage low current pulse which must be conditioned before use. So the conditioning circuit usually involves a rectifier with a small DC-DC converter and sort of energy storage device which we call it as a usually super capacitor, any sort of and where we can use it. Okay, so this is how we try to implement the piezo energy harvesting systems. So to generate electricity continuously, a constant oscillating source of mechanical energy is needed. This could be from vibrations, from running engines, or any other mechanical equipment. However, as the mechanical vibrations, move away from the resonant frequency of the piezoelectric element, dielectric power losses increase. So this can be countered by making the element the same resonant frequency as the source of the mechanical vibrations, which can be done by any varying dimensions. Varying the dimensions. The piezoelectric constant of the crystal is given, in the unit of coulombs per Newton. So obviously, this value depends on the material crystal which is made up of and the dimensions. Common piezoelectric materials, it can be naturally occurring or artificially occurring elements also. So naturally occurring materials can be quartz and the artificial occurring materials can be ceramic. Some other examples like zinc oxide, barium titanate, and lead zirconate. Thank you.